Alright, I'm going to be solving the USACO 2017 US Open Contest Bronze. Problem 3, Modern Art. So, art critics worldwide have only recently begun to recognize the creative genius behind the great bovine painter Picasso. Picasso paints in a very particular way. She starts with an n-by-n blank canvas, represented by an n-by-n grid of zeros, where a zero indicates an empty cell of the canvas. She then draws 9 rectangles of the canvas, one on each of 9 squares, numbered 1 through 9. For example, she might start by painting a rectangle in color 2, so it's 3 by 3 at the top left corner, and then she might paint a rectangle in color 7, which is going to be starting here, and then she might paint a small rectangle in color 3, which is going to be these two, right? And each rectangle has sides parallel to the edges of the canvas, which means that basically it has to have a length like this and a width like this. And a rectangle could be as large as the entire canvas or as small as a single cell. Each color from 1 through 9 is used exactly once, although later colors might completely cover up some of the earlier colors. Given the final state of the canvas, please count how many of the colors still visible on the canvas could have possibly been the first to be painted. So basically what it's asking is, when we have this completed painting over here, which is made up of numbers, which of these could have been painted first other than 0? Because 0 is going to be that empty canvas. And we see here that 7 could be painted first, right? Because no, 7 can't be painted first, because 7 seems to be overlapping over the 2's. Okay. And 3 couldn't have been painted first, because as it mentions here, 3 was painted over rectangles 7 and 2. So the only one left is rectangle 2, and that we see doesn't overlap any of the other rectangles and could have been painted first. So the first line of input is n, the size of the canvas, which is going to be a square, and the next n lines describe the final picture. And then we have to output the number of colors that could have been drawn first. So this problem seems pretty complicated at first, but we can probably notice a pattern in how we can determine which color has been painted first. So let's look at this example here. I'm going to color it in a dock for a second. Okay, so let's say that 2 is red, okay, so that the 3 by 3 squares were filled with red. Wait, I have to say that this is filled in red, right? Then after that, we know that all these squares are blank right now. Just make this more of a square. Okay, that's better. And then the cow paints colors of 7, which let's just say are like yellow or something, okay? Yellow. And we can already see here that yellow has overlapped the red colors, so that these 4 squares have been, they're no longer red. And then she places a small rectangle in color 3 in these 2 sections, so let's color those. Why not green? Sure. And we can see here that right now this is going to be the entire canvas, right? That means that within this canvas, we're trying to find out which rectangle could have been painted the first. So first, let's just go through each of the colors and try to find a pattern. So if we look at the green rectangle, we see that comparing to the red rectangle, we're not sure if it was painted first or painted above the red rectangle. So it could have been a possible rectangle that was painted first right now, since the red rectangle could have been painted here, and the green rectangle could have been painted here. Then there would be no overlap. But comparing it, the green rectangle to the yellow rectangle, we see that the green rectangle actually overlaps the area of the yellow rectangle, and we can determine the area of the yellow rectangle by finding its minimum values, x and y values, and its maximum x and y values. So since this is the entire rectangle that is colored in the color 7 or yellow, and the color green is inside of that the area of the rectangle, that means that the color green or the color 3 can't be one of the first colors to be drawn. So let's say there are colors 2, 3, and 7 right now, right? Green is 3, so green is not a possible color. Now we have 7, okay? We're going to be comparing 7. Yellow. Now we can compare it to red first, since it's going to be, red is going to be a lower number, but we see here automatically that red is, when it has the smallest possible area, it's still going to have a rectangular area of 2 by 3. And we also see that one of these areas is actually occupied by a yellow square. So that means that yellow also can't be one of the rectangles that was painted first. Since in red's area there is going to be yellow squares, so this can be one of the colors. And now we look at red. This is going to be red's area, right? So we look at yellow's smallest possible rectangular area, and inside we see that there is going to be no red color. Inside green's smallest possible area, there's also no red color. So this is going to be a valid color that could be painted first, which is why there's going to be one output. Okay, so what do we need to do? First of all, we need to organize all of this information, right? We're going to need some kind of two-dimensional array. We're going to need a two-dimensional array. And then we're going to need, we're going to use this to organize the data. Okay, and then we're going to need, let's say, some kind of, let's say, hash set. And this is going to get the colors, get all the colors. And then we're going to need, so for each of the colors, we're going to find its total area, or like the total area that it's represented by finding the minimum and maximum x and y values. And after we find the x and y values, we're going to probably need to keep track of what colors are inside of the rectangle. So in rectangle yellow, we would have to return green. So we're going to need some kind of function that returns colors within rectangle. And then after all of that, when we know how many colors are within a rectangle, we know that that can't be one of the rectangles that was painted first, since it's going to overlap with the rectangle. So we're going to need some kind of Boolean array, which is going to keep track of which colors work. And then after that, we're just going to have to find out how many of the values in the Boolean array are true, and then return them out. So find how many values in Boolean array true. Good enough. So we should probably start programming now, since we have the general idea of how to solve this. Let's see here. I'm going to split screen so we can see this. Okay. So what did we say we need? We're going to need an integer n, and we're also going to need the answer. We're gonna need let's make the array a character arrays to get in the entire drawing, since it's going to be fast and easier to utilize. And then we'll need a hash set. Let's make it character as well, which is going to contain all the colors, right? And then we're also going to need a Boolean array until it works, since we're going to be counting how many of the colors work. And then we need a scanner and a print writer for the USACO problems. Okay. We create our main. And inside of our main first, we have to throw an IO exception because we're going to be reading from a file. And after we initialize our scanner and print writer, we're going to need to first initialize everything. So we're going to need to set the values of n and fill the character array and so on. I think it's our yeah. Okay. First, let's initialize everything. So let's do that in a separate function. Okay, so first we get n, right? And then we have to fill our two-dimensional array. So canvas equals new car. Okay, so for now, I'm going to leave the second dimension blank because I'm going to do in.nextLine.toCar array, which basically splits the string into a character array. So int equals 0. Okay, and then now we have another step of initialization, which is to get all the colors that are going to be inside of this canvas. So colors equals new hash map. Okay. So hash. And then for every single color inside of the in the canvas, so we're going to need 2 for loops in order to see all of the indexes. Colors.add canvas. Okay, and we might think we're done, but we have to remember that we're not actually going to be counting the zeros inside of the canvas, right? We don't want that as one of the colors, so we're going to be doing colors.remove 0. Oh, and it's going to be a character. Character hash set. And then we're going to be doing our solve. That's another function. So since we're going to be counting the number of colors that could possibly work, of course, we're going to need to initialize works as well, which is going to be the amount of colors that could possibly work. So Boolean, actually we already initialized it, works equals new Boolean 9, since there are 9 possible colors and they're going to be 0 through 9. Actually it's going to be 1 through 9 since 0 isn't a color. And then for character I in colors, so from all the possible colors, works of I minus character 0, which turns it into an integer, minus 1 because it has to be indexed equals true. So we're setting all the possible colors inside of the canvas true for now. And after that, we're going to iterate through the array of colors and see which other colors could possibly be inside of its area. So for character I in colors, right? Okay. And here, let's just create a separate function in order to like count which other which other colors could possibly be inside the rectangle. And remember that we calculate the rectangle by finding the minimum and maximum x and y values. And we can just do that with a for loop iterating through the entire canvas. Let's say the new function is going to be called static. Let's see, what type is it going to return? Well, I guess we could return some kind of another hash set, let's say. They're easy to use. Overlap, let's say. And we're going to need the rectangle we're going to be analyzing at the moment, which is going to be a character. So car A, let's say. Now what we need to do is, first we need to initialize the hash set, right? Okay. And after that, the question is, how are we going to find the minimum and maximum x and y values for each rectangle? Well, what we have to do is, first we have to create 4 variables, let's say. So one is going to be the leftmost index, so int L. Others are going to be int R, which is the rightmost index, int U, and int D. I haven't filled them in now, but for L, every time we go through the array, we're going to be trying to find the minimum value that could possibly be the most left value for that color. So we're going to have to set L as the greatest possible index for now and use math.min, or find the minimum possible value that L can be inside the canvas. So since the canvas is going to be at most length of n, and n is going to be 10, but the index is going to be up to 9, we should probably set L to 9 since it's going to be the maximum index. R should be 0 since it's going to be the minimum index. Up should be 0. And down should be 9. Okay. So now we're going to have to go through each of the squares in Canvas, right? So for int I equals 0, I'll just oops. So right now we're just trying to find the largest possible rectangle, the smallest possible rectangle that can be created using the colors provided. So if the current rectangle, let's say canvas of I of j equals the character, then we're going to have to set left as the minimum of left and j, since j is going to be the horizontal length, or the horizontal index. And that's the same for right, but this time it's max, right, j. And then u equals max.max. This one's going to be I, since I is going to be the vertical index, and D is going to be math.max di. And now we should probably have the top left and the bottom right corners of our rectangle using the minimum and maximum x and y values. So now what we have to do is we have to go through this area again, and this time we're going to be checking which of the colors inside of this area are not color A. And if they're not color A, that means that they can't have been the one to drawn first, right? They can't have been drawn first in the canvas. For int I equals down, I is less than or equal to up, since it's going to be inclusive, plus int j equals left, j is less than or equal to right, since it's also inclusive. Now we're going to be using the hash map to know which colors are actually present. So we're going to do inside.add canvas I of j minus 0. And we're not going to be worrying about how there's going to be the color A inside of the hash set for now, because at the end we can just do inside remove A minus I. And it doesn't make any sense to do inside.remove 0, because if you're going to draw a rectangle, you can't possibly have a blank square in the middle of it, since the problem states that you have to draw rectangles. And then we just have to return inside, right? That should probably work. So now we're going back to the main for loop, and we're going to need some way to keep track of, let's say, the hash set that this function is going to return. So let's create another hash set here, and it's going to be a temporary hash set, and we'll call it inside. It's going to be overlap of I. So for int j in inside, so this is going to be the colors that can't possibly be the first color to be painted on the canvas. That means that works of this color and -1, since it has to be indexed correctly, this has to be false, right? Since it can't be one of the first colors to be drawn. And now we should have the Boolean array works full of the possible colors that could have possibly been drawn first. So now we just have to do answer equals 0, since we initialized answer up here. Int equals 0 is less than 9, since that's the index of works. So if that specific color works, then answer plus. And let's try it on the console for now. Let's try it on the console for now and see if it works. And of course we need to in.close and in.out.close at the end. Let's see here. Copy paste. Okay, we got a 3, and we're supposed to get 1 as our answer. So let's try to find what we did wrong. So integer.parse int. Okay, let's try printing out works here. Raise dot teach. Okay, so colors 2, 3, and 7. That looks right. So for in each of the colors, okay, let's take a look at the function then. Function 9009. Oh, down is going to have to be math.min. I think that's the issue. So we're going to be trying to find the lowest possible value. And yeah, it output 1, so you should try submitting it. Println. USACO. It's modern art. And it's pretty fast as well. Okay, I hope this video helped you solve the problem and maybe learn more about how to solve these kinds of problems. And yeah, thanks for watching.